Sir, good evening, sir.
Yes, good evening to all.
Okay, sir.
Let's start for the today session.
Yes, sir.
Yes, some question I taken are the
Sir,
revision class. Yes.
sir, I have more doubt in week 12 assignment questions, sir. I scored only 35 marks.
Okay.
Can we first discuss the week 12 assignment questions, sir?
What? Where is your problem? How much in
Sir,
assignment 12?
actually the graph related problems I can't understand, sir. So,
Waveform. A phasor
yes, sir,
diagram,
yes,
na?
sir. Yes, sir.
Phasor diagram.
Yeah, from the sixth question onwards, I zero marks.
Okay, okay. No, you can solve. I think there is a question without taking the phasor diagram also. Just
Okay, sir. Okay, sir.
just using the impedance J terms. They like a maximum power, average power absorbed by the loads. It is simply
Okay.
you have to find the RTS, ZTS and compare to this. And what is the ZL absorbed average maximum power? Same question. Question 6 and 8 are both are the approximate same. Simply you have to find the Thevenin equivalent impedance and compare to the like R plus JXL. That means ZL is equal to ZS conjugate. Which one is I only taught in the previous session. What for the maximum power? ZL should be ZS conjugate. We have to find the ZS as a ZTH, Thevenin equivalent impedance. By there's a dependent source, then you have to use the VI method. There, in this case, there is a V is AC source, V and I, and then you have to find the V by I. That one is a ZTH and uh, take the ZTH conjugate for the ZL. Then find the current. Then after we have to find the R into R, I square R. R which we need the in this ZTH. ZTH are R TH plus XL, JXL. Or you can say JXTH. This will be cancelled out by using a conjugate. Only this one resistance is there. Then you simply find the current and then find the power I square R in RL term. Question number
Okay,
7,
sir.
question number 8, or both are the same, I think. And what the question number 9, or the magnitude and phase plot of the voltage across the inductor in the circuit. This is the by using the Laplace thing.
This waveform is related with Bode plot, sir.
Bode plot, yes, yes. If you find that Laplace, take the Laplace of the circuit and find the output voltage divided by input voltage, then you get the transfer function. That transfer function you can find the Bode plot.
Sir, actually, circuit theory, Bode plot is higher level, no?
Okay, okay. For the circuit theory, it will. But simple it will. I think if you find the transfer function of this one, that will be simple, not too complicated. Only one poles are zero. If the 0 is there, it means S term is upper side, that means the magnitude will be increasing. And if the S term is a denominator, the magnitude will decreasing. Yeah, you can find the frequency also by putting the magnitude, putting the frequency value in magnitude. Yeah, you can find the zero frequency and infinity frequency, magnitude, and phase. Then we'll get the final answer. To check the options by using that one. And 10th also there, the magnitude and phase plot. No need to find the that's one is the body plot. Only find the magnitude and phase. Find the magnitude versus frequency. Put the frequency's value from zero value and some corner frequency value and then infinity value. Then we'll get the graph for that. Okay, let's start for the question. The question. The consider
Okay.
resistors shown above, shown below. If we apply 5 volt across it, we observe X ampere passing current through it. If we passes the 7 ampere through the resistor, we can see the voltage drop of X plus 2 across it. Then find the resistance value. This is the resistance. This is the current passing through it. It will drop some voltage V. Value is resistance I. It given as if you apply 5 volt across it, it means V. This one is V is equal to IR voltage drop. If you apply the 5 volt, then the observe that X ampere current flowing through it. It means this will be the XR. And say question number first. If we pass the 7 ampere through the resistor, then the voltage drop is X plus 2. That means X plus 2 voltage drop. Current is 7 ampere. This one is question number 2. By solving these two, we can find the value of R. From this, we can find the value of X, which will be 7R plus 2. Minus of 2. Put the value here. 5 is equal to X value is 7R minus 2 into R. This one. 5, this will be 7R square minus of 2R. 7R square minus of 2R. Go to the right side, this one. This will be a minus of 5. This will be breaks into two parts. This will be 7R square minus of 7R plus of 5R. 2R it breaks into two parts, 7R into 5 and 5R. You can take a common as 7R in the first one. This will be R minus of 1. You can common 5 here. This will be R minus of 1 equal to 0. This will be R minus of 1. First one. Second one is 7R plus 5. It means the resistance R is equal to 1 and minus of 7. 5 by 7. This is a negative value, no meaning of this one, that's why resistance will be 1 ohm in this case. Simply this one is a simple question given as simple resistor. In the place of resistor it will be a combination of resistance also. The equivalent resistance is this one. Then you have to go for this thing like that. Second thing, the coupling capacitor is coupling inductor is here. Find the voltage V1 and V2 in the given below circuit. There are two type of coupling actually.
Sir, voice is not audible.
Yes, now
Or
it's okay.
something explaining, right?
Now it's okay.
Now it's okay, sir.
Okay. There are two type of dot connection. Suppose this one is the V1 and this is the V2. For both the side, this is positive, negative. This will be positive, negative, and current is flowing like I1 here, I2 here. This is also I1 here and I2 here. Okay. But in this case, suppose this, take the question this one also. If this is the dot connectivity, this is also dot connectivity. Suppose one dot is here, another dot is here. This connectivity. There are two type of dot connection. This dot is same as this dot. Okay. It means if the current is entering at dot in one winding and secondary winding also entering from dot, that means these two are connected in additive polarities. And in the second one, if the dot connection is opposite, in first case current is leaving from the dot here, and in the secondary winding current is entering from dot. In this case current is uh, both of the winding are in opposition. That means there is a subtraction of the mutual inductance. Between two there is a mutual inductance which are known as the M12 in the both the case. In the first case, what is the V1? V1 is inductor. Here is inductor. Inductor have a current flowing. That's why this will be a first one L1. So this one L1, L2. This is also L1, L2, L1 di1 by dt. First inductance. Then second one, if a current is entering from the dot in primary winding and secondary winding, both are the same. That's why in that case we have to take a positive mutual inductance. Which one is a M12, and mutual inductance is occurring due to the secondary winding. That's why the current is a secondary winding current. Second one same as the V2. In the V2, the own winding is self winding is L2. L2 the current is I2. Then this one is di2 by dt plus this is the mutual inductance same M12, but this mutual inductance occurs due to the another coil which one is L1. Current is I1. This is di1 by dt. This is the current into editing polarity V1 and V2. Because of here both the current is leaving from the dot. It means both are the same connection. That's why the magnitude is positive in the both cases. That's why V1 V2 should be positive. I think this one both are the positive. Another winding in this case V1 is equal to self winding is L1 di1 by dt, but here is the dot connection is opposite. Current is entering into dot. Here the current is leaving from the dot. That's why this will be the opposition. In opposition, the mutual inductance should be a negative. It will oppose the own coil. That's why M2 by secondary current di2 by dt. Then the V2 is L2 di2 by dt negative of M12. This one is the di1 by dt because of the primary winding current. This is the combination to find the voltage. If the both are the dot connection is the same, the polarity of the mutual inductance is positive. If the dot connection is opposite, in that case the magnitude of the mutual inductance is negative. Okay. Third question. Third question I have taken from the circuit. There are two current source and a voltage source. Asking the calculate the power supplied by the voltage source. And it means this is the voltage source. Power supply, it means power current leaving from the positive. It means this direction. Current leaving from the positive, it means supply the power. Suppose take the current as I here. In this case, this current is I1, 1 ampere. This is 2 ampere. Both are coming in this node. Then the total current is this one is 3 ampere because of 1 2 ampere is this one, 1 ampere this one. If this is the 3 ampere, as this current is I, then what is this current? I plus 3. Again I plus 3 is coming here also. It means this current is I plus 3. Then after 1 ampere current is leaving here. Then this current is I plus 2. After that this 2 ampere current is leaving here. That's why this is the only current I. This is the I plus 2. This 2 ampere current is leaving here. That's why this current is I. Okay. Then we have to find the current I. How can you find? There is a single variable current I. That means you have to you need a single equation. If you have single equation, it can find the current by using a single equation. How can you take the KCL and KVL in this case? We have to apply a KVL. How can you apply? Can you observe that this one loop 1, suppose this is loop 2, loop 3, and another loop, suppose the full one. loop. This was suppose 4. Which one is better choice to take the loop? Anyone can guess in this question?
Outer loop, sir.
Outer loop. Yeah, this is the good observation. Why? Because of the in loop 1 and loop 2, there is a current source is there. Current source have some voltage drop across it, but we don't know about that. What is the actual voltage drop of that one? That's why they are difficult to use the loop 1, 2, and 3. All three loop are cons- considering the current source. In the case of the KVL, apply in the KCL any circuit, avoid the taking the KVL through the current source, because of the current source have some voltage drop, but you don't know actually what is voltage drop. That's why leave the all of three loop, this loop, and this loop. Use the only outer loop in this case. Apply the KVL started from here. That's when the first sign is minus of 10. Then after this one R1, R1 have a current is I plus 3, I plus 3 into R1. Then after this is R1, and you can take as a 2 R1, because of this R1 and this R1 are connected in series. Plus this R1 have a current of I plus 2, plus 2. Again this is the R1. Then after this R1, this R1 also, these both are 2 R1. You can take 2 R1. Then after this will be 0 equal to 0.
Sir, why 2R1 taken, sir?
Because of these two are the connected in series, and current is same, I plus 3, I plus 3. That's why R1 and
Oh,
R2 I taken as a 2
I,
R1. Same thing here also. R1, R1 I taken as a 2 R1. Multiply this one, this will be a 2 I R1 plus this will be 6 R1 plus this is a 2 I R1. This is a 4 R1 is equal to 10. R1, 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 R1. All is the R1. Have a resistance of 1 ohm. Put the value of R1. 1 ohm. This is the 2i. It means 2i. This is the 6. Plus this is also 2i plus 4 is equal to 10. 2i plus 2i is 4i. Plus 6 plus 4 is 10 is equal to 10. 4i is equal to 0. 10 minus 10, 0. I is equal to 0. It means there is no current passing through the 10 volt source. Now what is the power? Power is know about V into I. If the zero current passing through the 10 ohm 10 volt source, that's why the power delivered by that source is 0. That source does not deliver any power. Delivering the is not delivering the any power in this case. All power is delivered by these two current source only. Okay. Next question is I have taken like a super node uh, combination, because of these two node have a voltage source of 2 volt connected between two nodes. There is no resistance. From the below circuit, find the power absorbed or delivered by the 5 volt battery. This is the 5 volt battery. We have to find the power. Okay, it means we have to find the current of this one. We got the value of current, then you can say the actual power delivered or absorbed. It is depending on the direction of the current. There is a 3 loop. I taken as a 3 loops as loop 1, loop 2 and loop 3. Taking the current of this one is I1, this is I2 and this is I3. That means this circuit. To avoid the super node, if there is any confusion, simply take the, in place of KCL, take the KVL. In the KVL, there is no need of that node. This is 2 kilo ohm, 8 volt. This is also 2 kilo ohm. This is 3 kilo ohm. This is 2 kilo ohm. This is the 5 kilo ohm. This is 2 volt source. Oh, sorry. Okay. Take a current in this loop is I1. In this loop is I2. In this loop is I3. These are 3 variable. I require the 3 equation. 3 equation will get by the taking the 3 KVL in loop 1, 2 and 3. KVL in loop 1. KVL started from here. This is the plus 8. Then after minus 3 plus 2I1, 2KI1. I written as 2 only. K all less than kilo ohm. That means the current is in milliampere. 2I1 plus this is the 3. This I1 correct direction is downside and I2 is upper side. That's why I1 minus I2 current flowing through it. I1 minus I2 is 3 is equal to 0. This is 2I1 plus 3I1 is 5I1 minus of 3I2 is equal to this one 8 minus of 3 5. 5 goes to right side, it will be a negative. Question number first. Second loop I started here. In this case I2 is upper side, I1 is downside. That means this current is I2 minus I1 because we have taken the loop second. I2 minus I1 into 3. I2 minus I1 into 3 plus 2V, then here I2 minus I3 into 2, I2 minus of I3 into 2, and this one is 2I2 plus 2I2 is equal to 0. This is 3i2 and this is the 2i2, this is 2i2. 2 plus 2, 4 plus 3, 7i2. I1, 3i1 here, only 3i1 here, minus of 3i1. I3 minus of 2i3. Is a 2 volt, I replace plus 2 goes to right side, it will be minus of 2. Question number second. KVL in loop third started here, from here suppose 2 kilo ohm. Current is in this case I3 minus I2. I3 minus I2 into 2 plus 5 I3 is equal to this voltage is 5 volt plus of 5 volt is equal to 0. This is minus of 2I2. 5 plus 2 is 7I3 is equal to, this is the minus 5. Equation number 3. Take the value of I3 here. What is this one? Minus of 5 plus of 2I2 divide by of 7. And find the value of I1 from here. What is the I1? I1 is equal to minus of 5 plus of 3I2 divided by of 5. I1, I3 you can put the value at equation number second. 7I2 minus of 3I1. 3I1 is minus of 5 plus 3I2 I2 divided by of 5. Minus of 2I3. Minus of 2I3 is minus of 5 plus 2I2 divided by of 7 is equal to minus of 2. You can take LCM as 35 7 fifth is 35 35 into 7 I2 here, and this one is a 7 minus minus is plus 3 into 5 into 7, then this one is a negative 3 into 3 9 into 7 63 I2. This one multiplication of 5 here, 5 into 2 is 10 plus minus minus is plus, 10 into 5 is 50. This is minus 2 is 4, 4 into 5 is minus 20 I2 is equal to minus of 2. This will be 35 into 7 I2 minus 63 I2 minus of 20 I2. 35 into 7 I2 minus of 63 and minus of 20. This will be 162 I2. Then this will be plus 15 into 7, 3 into 5 into 7 plus 50, 155. is equal to minus of 2 into 35, it will be a minus of 70. Then what is the I2 in this case? I2 is minus of 70, then minus of 155 divided by of 162, 1.38 minus of 1.38 ampere. I2 is this one. Then what is the I1 from here? I1 is equal to minus of 5 plus 3I2 plus 3 into I2 is minus 1.38 minus 9.14 divided by a 5 is equal to minus of 1.828 ampere. Actually no need of this one, because of in the question asking about the I3, then type find the value of I3. Minus of 5 plus 2 into I2 is minus 1.38 divided by of 7, this is minus of 1.11, minus of 1.11 ampere. This is I3 current, minus of 1.11. Here this current is I have taken as a reference as current direction is this one I3, but the value of this one is minus 1.11 negative. Negative shows that the current direction will be reversed, which one I taken in earlier. That's why this direction current is flowing and the current value is 1.11 ampere. It means the current is leaving from positive. Current is leaving from positive, that means the power is delivered. If the current is entering from positive, that means power is absorbed. But here current is leaving from the positive, that means power is delivered. What power amount of power? 5 into current is 1.11, means this will be a 5.55 watt power delivered by the 5 volt battery. Okay,
So any shortcut is available
this one.
for this problem? Any shortcut method is available because it's taking more time. First to calculate I1, then I2.
In this case, if you want to find only I3, then no need to find the I1, I2, they directly find the I3. How can you find? By checking the value here, taking the same equation. Here, in the place of I3, take the value of I2 here and I1 here. I1, I2, find then the value find the I3. But they are taken some time also. But let's try the another method. If that one is work, then it may be okay. This value is 5 volt. By using source transformation, you have requirement only this current, no need of this one all thing. You can do anything in that case, but you have to find only this current I. Okay,
Yes, sir. Yes, sir.
then kind of source transform of this one voltage and a resistor, a voltage source and a resistor is connected in series R and V. You can transfer this one as a current source parallel with a resistor by using V by R and R, like that. This 8 volt
Okay,
and
sir.
this is the 3 volt. The total voltage is total voltage is 8 minus of 3 is 5 volt. just looking this one. This is a more negative than this one. That's why this sign is first. That's why 8 minus of 3 is 5 volt. I write actually minus plus 5 volt. Okay. Then you can transfer this one. 5 by 2 is the current. I can written as this one as a current direction according to the positive side. This will be 5 by 2, and this resistance is come into the series of 2k. Then find these two. You can find these two as equivalent 3 into 2 divided by 5, 6 Then after there is a resistance with value of 6.5, and the current is this one. Then you can change this one as the voltage source. Okay, by multiplying these two, 5 by 2 into 6 by 5, 5 cancel out, this will be 3 volt. 3 volt, and resistance you can add a series resistance of 6 by 5. Again these two are connected in series. We can add all is the left, this one, these two are connected, and this is the series. Again you can change this one in the source transformation in current and resistance. Like that you can change all of thing. Only this one and a resistant voltage source is here. You can simply use a KVL to find that one. Let's try. This is positive, negative 3 volt plus 2 volt is total is 5 volt. 5 volt, and the resistance is 6 by 5. 6 by 5 and 2 is in series. 6 by 5 plus 2, 16 by 5. Total resistance is 16 by 5. If you want to, you can change again this 5 volt. Then 16 by 5.
Sir, actually minus 2 volts, no, sir.
This one. There's another, this one 3 volt na. Which one is so by the source transformation?
It's minus 3 volts, no, sir.
This one minus this one minus this one. Both are the same polarity.
Oh, okay. Yes.
That
Oh,
time you
okay,
can
okay, I get
simply
it.
add this one. This was 16 by 5. Again we have try this one by using 5 volt divided by this resistance 16 by 5. This will be 25 by 60. This is the amount of current passing through. Then this current is 25 divided by 16 and parallel with a resistance 16 by 5. Now these two are connected in parallel. We have to solve these two. 16 by 5 into 2, or you can say this is the 16 by 5, it will be 3.1 or 3.2. Then use a 3.2. 3.2 into 2 divided by 5.2. But this is a lengthy question, you have to take some time. This is 1.23. This total combination are 1.23.
So in this problem, the I value is 1.413 milliampere, correct?
1.11.
Oh,
This is the, then after you have used and one more times. This resistance is 1.23 and this is the 25 point divided by 60, 1.56, 15625 is the current source, and this is the resistance. Then we have to multiply this one 0.23, 1.921 is the voltage source, and resistance is same 1.23. Then we have to add these two, 1.921 plus 5 divided by 5, 6.23, 6.23, this is approximate 1.11. Wait, this type if you solve direct by using a pencil and in our paper, then you can simply cut it down like that circuit.
Thank you, sir.
This is 25 by 16. You can remove this one by using 1.56, 1.56 ampere. This 16 by 5 is 3.2. If you combine these two resistances, then this resistances is a single resistance which value is 1.23. Okay, then once again if you want to change this one, then the voltage source is 1.921, then the voltage source is 1.921 and the resistance is same 1.23, 1.23. Okay, then you have to simply use I is equal to 5 plus this one is 6.921 divided by your impedance is 5 plus 1 is 6.23, 6.921 divided by 6.23 is equal to I is equal to 1.11 milliampere. Because of all the resistances are kilo ohm, that's why this will be in milliampere. Okay, same answer 1.11. This is also 1.11. But you, you have to check the forwardly to this one. Change this one by using a calculator. Simply change voltage source to current source, then after current source to voltage source, like that. All the calculation you can do on the calculator. That time this will be easy to solve.
But in the previously method is we are using KVL equations, sir.
Yeah.
But in physical calculator, equation mode is available. But in online calculator, there is no
Online
equation
calculator
solving
have
method.
some problem.
Yeah, that's a so source transformation is the better option for solving this problem.
Yes, yes. By using directly, is some easy calculator you can do like by your hand only. If someone is tougher calculator, simply use through combination like that, 3.2 into 2 divided by 5.2, like that calculator. Then source transformation is easy, faster than that one. But you have to take the carefully calculation. If any mistake is there, plus minus, then the answer will be changed. Okay. The next one I've taken as the from the dependent source. Find the value of V1 and V2. This is the V1. Both are the current source. One is the dependent source, current source, and one is the independent current source. We have to find this voltage and this voltage. Okay. This type of question simply solve on the paper only. Don't take too much calculation. Solve at you can do by your hand like that. This one is a 5 ampere. Suppose this is the 5 ampere. Taken like that, 5 ampere. One Ix is given. Then what is this current? This current is 5 minus of Ix. Because of 5 ampere here, Ix is going to this. They, that's why this is the 5 minus of X. And you know about don't know about this 8 ohm resistance. Then what is this current is given as 2 Ix. If 5 minus Ix is here, then 2 Ix is going to this side, then what is this current? 5 minus 3 Ix. Now you can say these two are connected across to each. That means this voltage and this voltage is same. What is this one? 8 Ix equal to this voltage drop 8 5 minus 3 Ix, and this will be 8 Ix is equal to 8 5 ja is 40 minus 24 Ix, and this will be 32 Ix. Ix is equal to 40, and what is the Ix? 8 5 ja 40 divided by of 8 4 ja 5 by 4. What is the V1? V1 directly connected to this one. This voltage drop is because of same. That's why you can say V1 is equal to 8 Ix. It means 8 into 5 by 4. This will be a 10 volt. What is the V2? V2 is this voltage. This is the 5 into 4. V2 is equal to this voltage drop and this voltage drop. This will be 5 into 4 plus 8 Ix. 20. 8 Ix is 10. V2 is equal to 30. V1 is 10. V2 is equal to 30. First I asking V1, and V1 is 10 and V2 is 30. V2 is 30. This one also. Option B is correct. These are reversible also there. 30 and 10. See the option carefully. First asking V1, then take the value V1 first. V1 is a 10 volt. It means 10 is first. Then V2 is 30 volt. Okay. V1 8 Ix because of, see here, these all three are connected across to each other. It means this voltage, this voltage, this voltage are equal. Because this one is 8 ohm resistance and Ix passing through current through it. That's why I directly written as V1 is equal to 8 Ix. Okay. Any question? Don't take a directly variable. Find the point which where there is a as low as possible variable you have taken. Let's as low as possible. Because of the one variable takes the one equation. If you take the two variable, it means there is a requirement of two equations. That one is the difficult to solve. Consider a circuit shown below. The resistance R in as seen by the voltage source. Here, this is an open question. Here asking about the R in. Impedances you know about the R in is equal to V in. Suppose take a current as I in. If you find this current, then this voltage is V in, resistance V in divided by I in.
Sir, one doubt, sir. In the
Yes,
previous case, Ix is 5 by 4, no?
Ix is 5 by 4. Yes.
4. Okay. But V1 is across 2Ix.
No, no. This is the current source is given. Current source value is given, not a voltage source. Don't confuse here. This value is a value of current.
Okay, okay, sir.
Because of this was the dependent source.
Yeah, okay.
That's why this is the current
No,
value.
no, actually the V1 is nothing but the drop across 2ix, right?
Yes, 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 yes.
So
When
if I multiply the ix into 2, that is a drop value, no?
no, no,
Not like
no.
that.
2 into Ix given as the value of current of that dependent current
Okay,
source.
okay. Okay, sir. Okay, sir.
And voltage drop across to Ix is the voltage drop, actually this thing. This voltage drop.
8ix.
8
Okay,
ohm
okay.
both. Yeah, this.
Thank you, sir. Thank you.
Yeah. Okay. In op-amp question, if the ideally op-amp, the input impedance is infinity. Input impedance infinity. Infinity input impedance, then V by Z, what is the current? V by infinity, current is 0. It means the current passing through this thing is 0 ampere. There is no current entering through the op-amp. If both are the 0 volt current entering, there is a 0 current. That means you can say the both terminal have a voltage equal. If there is a equal voltage, then what is the meaning of the current? Current is 0. The voltage difference is 0, then current is 0. That's meaning of this one. You can say the negative terminal and positive terminal both are the virtual short. Virtual short, why? Because of they both have a same voltage. This voltage and this voltage is same. They are same voltage. Same voltage, that's why current is not flowing through it. This current is,
Sir,
yes.
sir, is this one is fixed like negative feedback, no, sir?
Yes, yes, this is negative feedback. If the negative feedback is not there and there is a mentioning about the input current is this is ideal op-amp, there is also entering current is 0, but there is chances of the voltage difference may be differ, positive voltage and negative voltage may be differ, but current is both current is 0 if the ideal cases, in ideal cases. But agar if there is a negative feedback is there, that means they both are the virtual short. Both are the virtual short. There is no current through this thing. Okay. This is 10 kilo ohm. This is a 100 kilo ohm. This voltage V in, because of this shortage. This one. This is V in. If this is V in, this is also because of the virtual short. This voltage is also V in. If this voltage is V in, that is connected to this one. This voltage is also V in. If this current is I in, this current is 0, then this current is also same I in. Then what is the I in this case? This voltage minus of this voltage divided by of this one, because of all the resistances are in kilo ohm. This care about this one. All the resistances are kilo ohm and one is a mega ohm. Then simply put the value of this one as in kilo ohm, 100k. Put the value as all of the resistances are in same unit. Okay, put this one is a 100k. Then what is the IN in this case? Voltage difference, this voltage minus of this voltage V in minus of this voltage V naught divided by of 100,000. Okay, sorry. I replace the K, put the value as this one is in milliampere. But in this equation, we have requirement of output voltage. Output voltage will get from here. Apply the KCL in this node. It means this current is equal to this current. Because of this current is 0. You can, this was the ground 0, current passing between 0 minus of V in, 0 minus of V in divided by of 10K is equal to V in minus of V output. V output divided by of this one 100K. 1 0 is cancelled out, only minus of 10 V in is equal to V in minus of V naught. Then what is the V naught in this case? V naught is 11 V in. Put the value of V naught here, then this will be I in is equal to V in plus of 11 V in divided by of 1000. This is minus, that's why this is also negative. This will be a minus of 10 V in divided by of 1000. This B in going to this side, this will be B in divided by of I in is equal to minus of 1000 divided by of 10 is equal to minus of 100K. It means you can say R in input resistance is minus of 100K.
But resistance is always in scalar, no, sir. It doesn't. Why we put the minus?
Yes, resistance always in positive, but in this condition, you can say the sum of the amount of current are amplified because of there is a op-amp is there. In this case, op-amp has working like amplifier. The some value it may be amplified. Some current is maybe possibility the current direction of this one is given as R in maybe are negative. Because of direction is not given, only the R in direction is given. That's why I taken as this was a negative as the answer. This meaning of this one, it means the current direction is this one. But in this case, our negative resistance shows that the current direction is this one. Current is flowing like that. Because of the question is given R in direction, that's why I taken the current direction is same as the R in direction. That's why the R in is coming negative. In physical significance, in physical quantity, resistance is never negative. It should be a positive. Just because of the amplifier and some of the circuit where is the dependent source is connected, in that case is the maybe possibility that the equivalent Thevenin resistance may be negative also there. Negative is not negative soil is not meaning of the resistance is negative. It meaning of that was some quantity is amplified or current direction may be negative because of the V in divided by I in is resistance. This is the equivalent resistance, not physical resistance. Equivalent resistance it depending on the current direction. The maybe current direction will be reverse. It's showing that the power is delivered and absorbed. In case of delivering the power, it means the that source is absorbed the power. That is the negative sign showing. Okay. The next op-amp question I have taken as assuming the op-amp to be ideal, then the value of the output voltage value of output voltage is asking. Same negative feedback is all the op-amp, that means there is a virtual short between them. This is the 4 volt is connected here, that means this voltage is also 4 volt. Here 2 volt is connected, that means this voltage is 2 volt. Current, this one current is 0, this current is also 0, that means this current is same going through like that. Suppose this I taken as voltage 1, this voltage B not 2. Sorry. Okay. Then what is this current? This voltage 4 volt and this voltage is 2 volt. 4 minus of 2 divided by 2. Suppose I taken as this current is I, then what is the I? This voltage is 4 volt minus of this voltage 2 volt. 4 minus 2 divided by of 2 kilo ohm resistance 2k. This will be a 1 milliampere. This same current passing through this one also I. This is here also I, because of this current is 0. Here you can see this voltage is directly connected to this one, and the input current of this one is 0. That means there is no voltage drop. Here is no voltage drop. You can say the all current is going to this one. That means V naught 0 is same voltage here also V naught 0. If this voltage is same, then this voltage also, because of the virtual short, V02. This voltage is V01. How can you find the voltage? This voltage and this voltage. If two voltages you get the value of these two voltages, then we will get the final value of voltage, output voltage. How? What is this voltage? You can use the KCL here at this point at 4 volt node. Incoming current is this one, is same as the outgoing current. Incoming current is what is V0 naught minus this voltage is 4 volt divided by of 3k resistance is equal to same as 4. This current is 1 milliampere, and you can say this is 1 k multiplied by 3 is 1. What is the V01 is equal to 3 plus 4 is 7 volt. Same you can apply here also. This 1 milliampere current is flowing through this 2 volt minus of V02 divided by of 3k. 3 minus of 2 is 1. It means V02 is equal to minus of 1 volt. This voltage is minus of 1 volt. This voltage is 7 volt. This voltage is minus of 1 volt. Then you can use, because of this current is 0, KCL here. KCL at node minus of 1 volt. This one. This voltage, it means 7 volt minus of 1 volt divided by of this resistance is 5k is equal to minus of 1 minus of V naught divided by of 10k. 5 2 ja 10. This is 7. 7 plus minus plus 7 plus 1 is 8. 8 2 ja is 16. 16 plus 1 is 17. V naught is minus of 17 volt. Someone had doubt about this one. This voltage V02. Okay. this voltage V02, this resistance is directly connected to this one, and this current is 0. Because of this is directly connected, input impedance of this op amp is infinity, current is 0. If current is 0, that means there is no voltage drop at 4 ohm resistance, 4 kilo ohm resistance. This voltage V02, that means this voltage is also V02. If this is the voltage 02, that means because of the virtual short of these two, this voltage is also same V02. Yeah. You can solve the op-amp question like that by using simply using a virtual short and current input current is 0, then find the circuit path where current is flowing, then we'll get the answer. Okay. In previous class I solved this question by using the long method. If RL circuit RL series connected to the capacitor, then how can you find the value of dynamic impedance? If you want to try the find the impedance, Z is equal to know about this one, R plus j omega L parallel with the capacitor 1 upon j omega c. If you solve this one, it will take the long time. It will take a long time to find the uh, resonance frequency. Then after we have to find the dynamic impedance at that frequency. Then what is the simple method? Simple method that if there is any circuit have in parallel circuit, if there is a parallel circuit connected, a resistance and a capacitor, then in place of impedance, simply find the admittance in that case. Admittance, you know about the admittance is 1 by Z. Then in place of admittance, find the impedance, find the admittance. In parallel circuit, suppose R, L, and C, j omega L, j omega L, 1 upon j omega C. The admittance of this circuit is simply addition of all the three resistances R plus j omega L plus 1 upon j omega C. Like RLC series circuit. These three circuit is connected in series R j omega L 1 upon j omega C. You know about the impedance of this one is R plus j omega L plus 1 upon j omega C. In parallel combination, simply find the admittance. In place of impedance, find the impedance in series circuit, admittance in parallel circuit. Then that's one is easy to solve. Why it will look like that? If you have a doubt any, how it will look like that? Compiler is simply addition. In this case, suppose you have a voltage, I taken as voltage V and I. This current, this current, and this current. Know about IR, IL, IC. I you can say as IR plus IL plus IC. What is IR? V by R. What is the IL? V by J omega L. What is the IC? 1 upon R V divided by 1 upon J omega C. You can take a V common. I by V is equal to, this will be 1 by R plus 1 upon J omega L plus J omega C. This I by V is admittance. Sorry, I directly written this one. This is not actually. This is 1 by and this one plus J omega C. Okay, like that. Admittance of all three. It means admittance is admittance of R plus admittance of L plus admittance of C. This was the all positive. And admittance of R is 1 by R. We know about this. R is the only impedance, not a admittance. That's why 1 by R is admittance. Like that. Sorry. You can simply add this one. If you want to find the uh, resonance frequency in this case, what is this one? 1 by R. Plus, you can of this say that J divided by omega L plus J omega C 1 by R, take as J common. Then what is this one? Omega C minus 1 by omega L. At resonance, you know, imaginary part is 0. That means omega C is equal to 1 upon omega L. Simply omega is equal to 1 by root of LC. What is the frequency? 1 by 2 pi under root LC. This is the resonance frequency in parallel combination of the RLC circuit. Same as the series combination also. You can take these two as equal to 0. Then in this case also, resonance frequency is 1 by 2 pi under root LC. Okay. No need to solve the impedance in this circuit. If you want to solve the impedance of this circuit, it will take a long time to find the resonance frequency. That's why in parallel circuit, try to solve the admittance, not the impedance. Okay, like that. This circuit is RL with the C circuit. How can you find the admittance frequency, resonance frequency in this circuit? Okay, this circuit is simply a resistance, a inductor, and a capacitor. This is R, this is J omega L, and this is 1 upon J omega C. What the admittance of this one? Admittance of this one plus admittance of this one. Admittance of this one is impedance is R plus J omega L. So admittance 1 upon R plus J omega L plus this one 1 divided by admittance impedance. This will be J omega C. Admittance is R plus J omega L plus J omega C. We have to remove the imaginary part in denominator, and this will be R plus J omega L multiplication of R minus J omega L divided by f r minus j omega l plus j omega c. This will be r minus of j omega l divided by f this square plus this square r square plus of omega l square j omega c. You can separate the real part and imaginary part, r square plus omega l square plus of j. This is the omega c minus of omega l divided by of r square plus of omega l square. You know about at resonance. At the resonance, imaginary part is 0. That means omega c is equal to omega l divided by of r square plus of omega l whole square. Omega is cancel out. That means r square plus of omega square l square is equal to L by C. What is omega in this case? Root of L by L by C minus of R by L square. Why? Because of this one omega square. Sorry. Because of this one omega L square is equal to L by C minus of R square. If L square is oh sorry if L square is here, that means this is L by C. L by C, L cancel out, only 1 by LC is there. L is there, not L 1 by C. Okay. If omega is this one, what is the dynamic admittance? R square cancel out. This will be a R C by L. This is the admittance, dynamic admittance. What is the impedance? Opposite of this one, L by RC. If there is any parallel circuit, then simply try to solve by using the admittance in place of impedance. If you go to taken this one impedance, then this will take a long time, a long step also to solve behind the input natural frequency, uh, resonance frequency. But in this case, simply use the admittance problem. Then impedance admittance both are 0. The imaginary part is 0. That's why put the 0 as imaginary part in this case. Then find the resonance frequency. With resonance frequency, once you get the resonance frequency, then don't put the omega value here. Put the omega L square value directly. Okay. Next question: if the voltage VAB and VBC, this voltage and this voltage VAB and VBC both are same, which means magnitude of VAB is equal to magnitude of VBC is equal to 100
Sir,
volt. Yes.
sir, in previous question, they are asked the dynamic impedance, sir. Value, no, sir.
Yes, yes. There is a find a value. Previous session already
How can
I
L
solve after
value,
that.
C value not given, no, sir?
Yes, yes, yes. You have to find the LNC also. But previous say class I solved the value also. That's why I leave this one question. But if you want, I can solve. Here is given as something value value of resonance frequency is given. F is 500 kilohertz. Okay, and bandwidth is given. Bandwidth is given. Bandwidth, you know about the bandwidth is equal to F is equal by F Q naught. F naught divided by of Q. Why is Q is the quality factor. F and naught divided by of Q. Q is quality factor is omega naught L divided by of R. Bandwidth is given as 20 kilohertz. This is F naught cancel out. This will be R because of omega is 2 pi F. Only 2 pi L is there. R value also given as 5 ohm. Put the value of 5 ohm. Then what is the L value? 5 divided by of 2 pi into 20 into 10 to the power of 3. Then value of L, if you solve this one, this will be a 39.8 microhenry. Okay. A resonance frequency is given. Where value of L, R, only C is there. Here is the resonance frequency. Now you can put the value here. F naught is given as 500 kilohertz. Can you find this value? Omega L. How can you find? 2 pi into 500 into 10 to the power of 3 into value of omega L is 39.8 into 10 to the power of minus 6. Then what is the value of omega L? Don't try to find directly the value of F. Value of omega L for the easy calculation. 2 into 3.14 in this is a 500 10 to the power of 3. 5 into 2 is 10 10. This will be 100. 500 into 2 is 1000. 1000 will cancel out, only 39.85. This will be 124.97 value. Minus of R square. Minus of R. R is 25. R square is 25. This will be 99.97. Sorry, this will be 124.97 square minus of r square is 25 minus minus plus of 25 because I was is equal to L by C. Try to solve like that. Don't try to put the value of this one is 2 pi f and then find the value of all of things, the square and root. This will take the long time. Simply find the value of omega L. Once you get the value of omega L, then square this one plus of this one. 124.97 square plus of 25. This will be a 1564.2.5 is equal to L by C. Then what is the value of C? Value of C is simply inverse this into inductance value. Inductance will 39.8 into 10 to the power of minus 6 divided by 1564.2.5. This will be a 2.55 nanofarad. Then jet dynamics is equal to value of L, which will 39.8 into 10 to the power of minus 6 divided by f. R is 5 into C is 2.55 into 10 to the power of minus 9. This value is 3.128 kilo. Okay. Simply after that you have to find the value of inductance. Inductance value you can find by using the bandwidth, and using the frequency you can get the value of capacitors.
Sir, your voice is not audible.
Oh, sorry. Sorry. Further, if you want to use this one by using the impedance method and magnitude method, it will take a long time to find the resistance value. Yes. Okay. This one you can get the value of inductance easily. But if you want to go for this one, This will take too much time because of the RC circuit. You can try, but in place of this one, use the phasor method to solve this question. How can you solve this one? By using phasor method. A series parallel capacitor and resistor combination. Then after there is a current of 5 ampere and voltage across it is 100 volt, 50 hertz is given. Magnitude of these voltages is given as A, B and C is 100 volt. It means magnitude is same. Okay. What is this current? I taken as IC. This current I taken as IR. This current is same as IL, which was same as 5 ampere is given in the question. This will be j omega L. This is 1 by j omega C. Okay. There are two voltages VBC, VAB, and VBC. There is a capacitor and inductor is there. Suppose only capacitor, only inductor is there. The what is the phasor diagram in this case? You can say as VAB, this voltage is also same as the IR into resistance. Na. In this case, this voltage drop is the same as this voltage drop, and this voltage drop, magnitude of this voltage drop also same. In parallel combination is there. Because of the parallel combination. Okay. If I draw a line which one denoted as the phasor of VAB, which will be 100 volt is given in the question. VAB, this voltage. I take as a reference as this voltage. If this voltage is reference, then there is some voltage angle difference between this one and this one. What about the voltage difference? We don't know. Then I taken as this will be like that. Value of this is BC. It will be same as the 100 volt. And the phasor sum of these two is the total voltage of 100 volt is given. Suppose if there is a not resistance is there, only capacitor is there, the voltage difference between capacitor and inductor will be 180 degree opposite to each other. If inductor is value is here, then capacitor value is here opposite to each other because of BBC. It means you can say BAB is equal to minus of BBC. Why? Because of the both have the same we have the equal magnitude of the voltages. If the resistance is not given, but here the resistance is there, that's why the voltage angle difference is less than the 180 degree. How much this one? We don't know about that. Then we have to find by this one. Phasor sum of this thing phasor sum of these two is total voltage supply. It will also same as 100 volt. Okay. Suppose the angle difference between two is alpha. Then you can say Vs, what is this one? Root of VAB square plus VBC square plus 2 VAB VBC cos alpha. What is the Vs? Vi is 100 volt. VAB magnitude is also 100 square plus this one also 100 square. This one also both are the same. It means 2 into 100 square cos alpha. You can take a 100 square common, then the outside of the root is 100. 100 will be cancelled out. This will be 1 root of 1 plus this is 1 plus 1 is 2. 1 plus 1 is 2 plus 2 cos alpha. Can you take a square at the both side? If a square is of the both side, then this will be 1 is equal to 2 plus 2 cos alpha. Then what is the cos alpha? 1 minus of 2 is minus of 1 divided by of 2 half. That means what is the alpha? Alpha is cos inverse of minus of 1 by 2, which will be 120 degree. That means alpha is 120 degree. The angle difference between these two is 120 degree. Okay. I have taken as the reference as VAB. VAB angle 0. That means the resistance current is same as the phasor with the VAB. It means IR. N. Then if this is the IR, this is a capacitor current. Capacitor current exactly uh, displaced by the 90 degree. Then this will is the 90 degree difference of IC, and the sum of these two is 5 ampere. IR plus IC is equal to 5 ampere. Also same as the IL, you can say the IL current is same as the IC plus of IR. IL is 5 ampere given in the question. This means the IC current plus of IR. That means the equivalent of these two have current of IL. In the inductor, the current and voltage difference is how much? 90 degree. An inductor and a capacitor voltage difference is 90 degree. That means this is the inductor current, inductor voltage VBC is the VBC, and what is the inductor current is IL. What is the difference between these two? Is 90 degree. If the difference between these two is 90 degree, then after this total difference is 120 degree, then what is this one? This one is a 30 degree. It means angle difference between IL and IR is 30 degree. From this phasor, you can say IL is equal to IR, IR is equal to IL cos 30 degree. IR is equal to IL. This current is a magnitude of these two, IC and IR. IR is this current and voltage angle difference between them is cos 30 degree. IL is 5 ampere. Cos 30 degree, you know about root 3 by 2, and this will be a 4.33 ampere. If IR is there, then you can say the what is the R? VAB divided by of IR. VAB a 100 volt divided by of IR is 4.33. This is the 23.09 ohm. Is a resistance 23.09. You have to find the phasor diagram of this question. Because of this is the combination of series combination of capacitor and inductor. That means both are displaced by the 180 degree, capacitor and inductor. But due to the resistance, there is a voltage, there is a phasor difference maybe less of the 180 degree. How much we don't know. How can we find? There is a voltage is given VAB, VAB, and total voltage is also given. Then you can use the magnitude formula, which one is the VS is equal to VAB square plus VBC square plus 2AB VBC cos alpha. In this case, you can find the angle difference between these two. Which one is the 120 degree. Okay. Once you get the angle difference between these two is 180, 120 degree, then you know about the inductor is current, suppose I, and this suppose VL is voltage IL, value of this one is j omega L, you know about this one. Then what is the VL? VL you can say as j I into omega L. Suppose VL is some angle 0 degree, suppose 0 degree, then what is the I in this case? VL by j omega L. What is the I? IL. VL j omega L, j is VL divided by omega L, j 1 by j divided angle is minus of 90 degree. It means the angle difference between voltage and current in the inductor and the capacitor is 90 degree. This is the IL. This is the current of IL, and this is the voltage of VL given in the question VL, because of there is a single inductor only. The voltage of VBC. The voltage difference, angle difference between these two is 90 degree. If these two voltage difference 90 degree, then what is the voltage angle difference of these two? 90, 180 minus 90 is 30 degree. Then 30 degree, then IL is the combination of IC and IR. The IR is IL into cos of this angle, cos of 30 degree, remaining angle is 30 degree. That's why you can find directly IR value. If IR value is there, then you can use the VAB divided by of IR is R. You get the answer. Okay. And if you want to try this one by using impedance method, then I can do, but it will take the long time to impedance, find the impedance. Okay, everyone. I want to stop this thing here.
Sir, any shortcut is there for this problem, sir? This also take more time.
This is the shortcut only. If you know about the phasor diagram, then you can solve this thing very less time, because only this calculation is there. Nothing another thing. There is no calculation. Only this one. 120 degree. Then you can only the phasor diagram. There is no calculation.
Whether we have to mug up this as formula
There is no directly formula
IR
for this one.
IR equal to IL cos
Ah,
30
this
degree.
one. Because of this one, if you know, if there are two vector, IR, IC, and the combination of these two have some uh, value is suppose I, and angle difference is this one is theta. Then if you want to find this IR, if the base is theta is connected, then that side, in this case, IR is IE cos theta. Opposite of this one is IC. That means IC is I sin theta. Why can you written directly? Suppose this is AB. Alright. This thing suppose AB. This is suppose CD. This is a triangle. Na. Right angle. This is 90 degree. This is a right angle. This is the
Yes, sir.
base.
Yes, sir.
This is the base. This is a perpendicular. Sorry. This is the perpendicular. This is the hypotenuse. But you have country want to find the IR, this thing and this thing, base and hypotenuse. In which formula we will get? Cos cos theta is equal to hypotenuse divided by a base. Base divided by a hypotenuse. Cos theta base is IR, hypotenuse is I. Then what is the IR? I cos theta. This formula comes from here. A right angle thing using the trigonometry in right angle, cos and sine.
So this type of problem only will come, sir, for the final exam.
Maybe chances some it is not this type of complication, but some formula, some question is maybe come from the phasor diagram. From phasor diagram you can solve easily, but same thing you can draw for the impedance method, and impedance method will take long time to solve by the impedance, because there is a equation, lot of equation IJ form. That's why there is problem. By impedance method, we will get the value of here omega L. L value to find directly. Then we can say the multiplication of current, magnitude of the current into this impedance ZAB. Impedance, current into impedance is voltage. This voltage is what? 100 volt. VAB given in the question. Then what is ZAB? ZAB is 100, which is 20. ZAB is 20. Then you have to find this impedance R parallel with 1.0 omega c. These are two variable c and R both. Then you have to find one another equation to get this value R plus j omega c, R plus 1.j omega c. So R into 1 by j omega c, then R plus 1 upon j omega c. This is equation number first. Another equation you have to take that both j omega l plus R into 1 by j omega c divided by R plus 1 by j omega c, magnitude of this thing into I is equal to also 100 is given. This voltage, this is also 20 because of I is okay, I written as this is B. Yes. Then there is two equation. We have to solve these two to find L is the already find, then only R and C is variable. But this will take a long time. That's why I try to solve this question by using a phasor diagram. Okay, thank you class to all of you and best of luck for your exam. Yeah, thank you Arulji.
Hello, sir.
Yes, yes.
Thank you, sir. You have explained so patiently, sir. Thank you, sir.
Okay, welcome sir. And best of
Thank
luck
you,
for
sir.
your exam for all of you.
Sir, I having more fear, sir. My internal is only 18, sir,
Yes, yes,
out
yes.
of 25. My internal marks I counted only 18 marks out of 25.
Oh, okay.
And external also, this much of time it will take means using online calculator, it's very difficult.
Then you search the Google and find the online calculator and try to solve there as practice as more. Then you can uh, solve easily in that in the exam and save the time. Practice, do the practice more by using the virtual calculator. There's a Google type you can get the virtual calculator.
In Google Play, in Google Store, there is this calculator, sir, Gate calculator, which is similar to TCS Ion
Same
calculator.
to same. Google Store also have a same virtual calculator. You can practice there also.
Scientific calculator is there.
No, not a scientific calculator. Well, the
Yeah,
gate calculator you can say.
Gate calculator is there, sir.
Gate
yeah,
calculator
yeah.
is there in the Google Store.
Yeah, but the no use, no, sir, because problem and all many take more time, many more subdivisions.
Yeah, there's problem, but in this case, try to like some. I give some hint. If there is some calculation like some equation to solve 2 into 1 by 5 or to solve this one like 0.2 no, plus 3 plus 4 into 5 like that formula, and the denominator also here 9 could it 8 plus 2 could it 5 plus 10 like that. No, first solve denominator, not directly use the numerator. The first solve this thing, then after simply use of this thing, reverse of this one. First solve this one, reverse of this one, then take a bracket and write this thing
Okay, sir.
in virtual calculator, then you'll get the actual value. In this, if you try this one to divide by this one, then this will take some time.
Okay, sir. Understood.
Uh-huh.
Thank you, sir. Thank you.
If there is only one thing like 1 by something, don't try to put the value like 1 divided by all of thing. No, first try this one, inverse this one only. This type of practice you can do, then this will be better. Okay.
Thank you, sir. Thank you, sir. Sir,
Okay.
we can refer only 12-week assignment is enough, sir, for passing the examination.
Yes, yes, yes. Enough.
Thank you, sir. Thank you very much.
Okay. Okay. All the best.